Greetings, welcome to the first of a series of videos on the weather history of Canada. Why? Because everyone is talking about the weather and yet no one seems to know anything about its history. I talk to people about this all the time, and it's really shocking how little people actually know about it. How can one put the present into perspective without knowledge of the past? Where to start? We'll start with heat. In Canada, 32 degrees Celsius is hot. So we will look at how often the temperature hit 32 degrees or more year to year. This is by no means the only way to look at it, but we have to start somewhere. We'll start with Toronto. Why Toronto? I know. Everyone hates Toronto unless it's the Raptors. But according to the CBC, hatred of Toronto is the last thing holding the country together. So it must be true. The real reason is that in Canada, the oldest complete weather data from a consistent location is from Toronto, specifically the downtown campus of the University of Toronto. It is important that the data be taken in a consistent location. When one is looking at long-term trends, the difference of a degree or two becomes a big deal, especially when there are people claiming that a long-term change of a degree is a potentially earth-shattering event. Moving a collection point can and does make a difference. Mixing data from different locations can easily hide, change, or exaggerate a trend. This should be obvious common sense, but as we know, facts don't matter when you can just scream very loudly. I dwell on this point because it is a problem that plagues the Canadian Weather Database. So we'll start with Toronto. This graph shows the number of days the University of Toronto reached 32 degrees each year from 1840 until 2018. No rounding up was used. The temperature had to fully reach 32 to count. It also has a 5-year moving average. We see mostly low numbers through the 1800s. This is not surprising as we are emerging from the Dalton solar minimum, which followed the Little Ice Age. This was followed by a significant rise in the early 1900s, then a noticeable drop in the late 1970s, and a somewhat higher level since then. We also see that a year with a lot of high temperatures can be followed or preceded by a year with very few. The second graph displays the same data grouped into 5-year periods. The last bar can only contain partial data for 2019. The overall trend is clear. It also serves as a warning for when you see graphs that start in the late 1970s. When you see that, a warning bell should go off. Always demand to see what happened before the start line of any graph someone shows you. And that is not just for weather graphs, of course. That's Toronto. What about the rest of the country? Let's go to Calgary at what is now the airport. Data for Calgary starts in the 1880s. Calgary does not hit 32 so often, but we do see a similar major peak in the late 1910s and a lower peak in the 1930s and 40s. Since then, we see a hot summer from time to time, but definitely lower numbers. The 5-year graph is very clear. The period 1910 to 1944 dominates the graph. Medicine Hat hits 32 far more often than Calgary or Toronto. Nonetheless, we see a similar peak in the years after 1914 that tapers off in the 1940s. The 5-year trend graph for Medicine Hat shows that temperatures 32 or more are common, but they were more common 80 to 100 years ago. Regina has a gap in the data from 1888 to 1897. The pattern is a bit different, but the major peak again comes in the same late 1910s to the 1940 period. The 5-year graph gives a clear peak in the 1930s followed by a dip, returning to a plateau in the 60s to 80s with lower levels since then. Saskatoon also has gaps in the data in the 1890s. Here the numbers go up and down, although there seems to be a concentration in the 1930s. 5-year data clears this up just a bit. There are alternating peaks and valleys, but the overall trend is down. Here we must pause because we've almost run out of locations with consistent data collection points. It would be good to immediately include Montreal, Vancouver, Halifax, and others, but these places have moved their collection points, in some cases several times. An honest presentation has to distinguish between these. This is the tragedy of weather data in Canada. There is a lot of it, but it is chaotic. What usually happened was data was collected in a municipality. Later an airport was built and the weather data was then collected there. This usually happened between the late 1930s and the early 1950s. In some cases, there are decades-long gaps in the data. The far north above the 60th parallel has little data before the 1940s, and temperatures reaching 32 degrees are very rare there. There is Montreal data as early as 1742, but with long gaps and location changes. The consistent Montreal data starts in 1871, but it falls off in 1992, and we have to then use a different location. There's no choice but to use some of this imperfect data. Moving from east to west, we start in Moncton. St. John's, Halifax, and Charlottetown rarely or never reach 32 degrees, so for now we have to leave them aside. Moncton gives city data until around 2009. The airport data starts in 1940. Moncton doesn't get to 32 that often, although it did in the 1940s and again in August 2001. The 5-year data shows the city reaching 32 degrees more often than the airport. There are reasons to expect that, but we won't address them just now. The number of hot days peaked in the late 1940s and again in the 1990s up to 2002 before tapering off. Montreal data starts in 1871 at McGill University and ends in 1992 with the Dorval Airport data starting in 1941. We see most years hitting 32 2 or fewer times. There are peaks of 14 in 1921 and 1955. There is no obvious pattern to the peaks. The 5-year data shows that since 1911 the number of days has gone up and down in irregular cycles. The last few years are at one of the higher levels, but by no means the highest. I have looked at the chaotic pre-1871 Montreal numbers. The results were very unusual, but I hope to present something regarding those in the future. Winnipeg gives us city data until 1938, then shifts to the airport. There were certain very hot months such as July 1886, July 1936, and June 1988. The consistently higher years were in the 1930s. Recent levels are much lower. The 5-year data shows a concentration in the years 1928 to 1942, a notable peak in 1988 to 92, and then a drop to much lower levels. We arrive in the far west with Kamloops. The city data ends in 1950, then restarts in 1962 to 82, with the airport starting in 1950. Kamloops hits 32 degrees consistently. The city seems to hit 32 more often than the airport. The recent years do not hit the peaks of some earlier years, but the average per year does seem higher recently. The 5-year data supports that observation. Around 2000, the numbers rose to reach a plateau that appears to average higher than any of the previous plateaus. Vancouver almost never reaches 32 degrees, so we have to settle for Nanaimo on Vancouver Island. Here the airport seems more likely to hit 32 than the city. There are peak years in 1958, 71, and 77, but a majority of the years are 4 or less, and does not seem to be a trend except for a peak once in a while. 5-year data seems to show a recent upward climb, and yet this apparent climb contains 3 cooler years in 1999 to 2001, and 3 more in 2011 to 13. In this case, the year-to-year data might be more informative than the group data. Lastly, I want to show Welland, Ontario. Why? It also has almost continuous records going back to 1872, one of the few such places. Recently, the location has been moved 7 kilometers outside the city, but in this particular case, the impact of that appears small. Also, Welland is a small city, not far from Toronto, and a contrast to Toronto, which is now a large metropolis. There are reasons to believe that large urban centers act as heat islands which raise local temperatures. This is another topic for later investigation. The chances of hitting 32 degrees in Welland were much greater in the past, and there has not been a peak since 1988. The 5-year data illustrates this clearly. The greatest frequency of hot temperatures was seen in the period 1895 to 1949. Let's wrap up this look at these 11 locations. What has been most noteworthy is the number of years with hot temperatures in the period 1915 to 1950. The 2 cities in British Columbia are recently at a high, while the rest are at a much lower level, and several are at near their historic lows. This data is publicly available, and anyone who accesses it will come up with the same results. One last thing. I'm going to ask you to Be honest with yourself. Did you know any of this before watching this video? Further, has anyone previously told you anything about it? Certainly I wasn't aware of it until I decided to find out for myself. With all the talk going around about the weather recently, why is that? Please think about that. Discussion and investigation must be open and honest and based on real raw data that has not been tampered with. Thank you for watching.